In the next two lessons, we'll be taking a look at the sine and the cosine law. And we use these two laws because what happens when we don't have a right triangle anymore? We can't use sine equals opposite over hypotenuse. We can't use SOHCAHTOA anymore because that depends on it being a right triangle. So if we aren't given a right triangle, the sine law and the cosine law come into play. And in today's lesson, we're going to be looking specifically at the sine law. So the sine law is an expansion of a fundamental trig ratio into a law that can be used on any triangle, non-right triangles included. It states that the sines of the angles of a triangle are proportional to the lengths of their opposite sides. So on the right here, we have the sine law, and you'll notice that it can be written in two different ways. And this is because it represents a proportion. So it means that there's some sort of relationship between the angle and its opposite lengths. And this relationship is the same for all sides and all angles. It's easier to solve a proportion when the unknown is in the numerator, so at the top. So when the unknown is an angle, use this form. And when the unknown is a side length, use the second form. And this is because if you use, let's say we're trying to find a side length and we use this one, that means that our unknown would be on the bottom, right? And we would have to do a few extra steps in order to find what, let's say, A is. Whereas if we have our unknown at the top, we can go directly and multiply by sine A. And we'll see some examples in a second. So when can we use the sine law? There are two different scenarios where we can use the sine law. First is when we are given two angles and a side for an acute triangle. So we can use the angle sum of 180 degrees to find the third angle and then set up a proportion to find any side we want. So let's say, in this first example, we are given this one, this angle, and let's say we're given this. So since we know that all the angles in a triangle add up to 180, could we find C? Yeah, we could. We could do 180 minus this angle, and whatever is left would be this. And then we would be able to use the proportion and find any side. So that's one scenario. Another scenario is if we're given two sides and an angle opposite one of them. So let's say we have these two sides and we have an angle opposite to one of them. So let's say we have the angle that's opposite to side length C. We would then be able to use this proportion in order to find this. Or we could, so using this proportion, we could find this, okay? So basically, just to sum that all up, we can use the sine law when we have a corresponding side angle pair plus another piece of information. So this side angle pair means that we have an angle, and we have the opposite side. Okay? So I'll highlight the ones that are opposite sides so that we can see a bit more clearly. So angle A, it's opposite to this side length. So this angle is opposite to this one, right? If you go across, you'll reach here. This side length is opposite this angle. This side length is opposite this angle, okay? And that's how you can make sure that you know what a side angle is, because it's always the ones that are opposite each other, okay? Always the angle and the sides that are opposite to each other. All right, let's take a look at some examples. So let's say we're given two angles. So we have a triangle PQR. We're given R is 68 degrees, Q is 69 degrees, and P is 21. So let's first draw this. So you can draw a triangle, any shape really. label any side PQR. It doesn't really matter. Okay, and that means, so if R is 68 degrees, this is 68. Q is 69 degrees, and P is 21 degrees. So it matters what you label as 21 degrees. P is 21. So P has to be opposite angle P. So it means that this side is 21 centimeters. Okay, so it's very important that you understand how to label your triangle, because that will dictate how we then solve the triangle. Okay, so if we're asked to solve a triangle, what that means is we need to find all angles and all sides. Okay. So basically, we have to get all the information we can about the triangle. Let's first figure out our remaining angle here. That, remember, is quite easy because we know all the angles in a triangle add up to 180. So in order to find what's left, we take 180 degrees and just take away what you have. Okay. And you will get that angle P is equal to 43 degrees. And we can add that in. I'm just going to add in a different color so we can differentiate what we knew before and what we know now. Okay. Secondly, let's see, we just need to look for these two sides now. Okay, so in order to find these two sides, we'll have to use the sine law. Okay, and we can use the sine law because we are given two angles and a side. Well, in this case, we have three angles and a side. Okay, so in order to set up the sine law, we need to set up a proportion. So let's first find side Q. Side Q would be this side length because it's opposite angle Q. So we're looking for this one. And we know that we're trying to find Q. It corresponds to sine of 69. So if you look back at the sine law, we'll use this format because we're trying to find a side length. So side length A over sine of A is equal to little b over sine of B. Okay, let's use that. So Q, little q, is over sine of big Q is equal to, so the only proportion we know is P because we have this angle and we have this side length. So little p, side length P, over sine of angle P will give you the correct proportion. So in order to find Q, let's isolate for Q. So right now Q is being divided by sine of 69. So let's multiply by sine of 69 degrees. So that means we have to do it to both sides. This is gone. And we get that Q is equal to 21 divided by sine of 43 times sine of 69. Put that in your calculator and see if you get 28.7 centimeters. That means that this side is 28.7 centimeters. Okay, let's take a look at the third one. So lastly, we're just missing little r. So same thing, let's set up the proportion. So little r over sine of big R is 68 is equal to, let's use what we were given. So let's use little p again. So 21 over 43 degrees, sine of 43 degrees. And again, we'll multiply both sides by sine of 68. And you'll get R is equal to 28.5 centimeters. Okay, so you want to get comfortable with using the sine law, how to set it up. And we'll look at another example where we have two sides and an angle opposite one of them. So we're asked to solve triangle ABC. So let's again draw a triangle. Okay, Doesn't really matter what shape it is or which sides you label A, B, C, but it does matter how we label the angles and the side lengths. So we're told that angle B is 75 degrees. So this is 75 degrees. Little a is 8.3 degrees. So that means that this side length has to be the one that's opposite angle A. So angle A is here, which means that this side is 8.3 centimeters. And we're also told that little b is equal to 10.4. So little b has to be opposite angle B. So find angle B wherever it is on your triangle and label the opposite side. So this is 10.4 centimeters. And again, we're asked to solve angle ABC. So in order to do that, why don't we get another angle? So we're given this proportion, right? Let's then find and finish up this proportion. So we're trying to find angle A. Okay. In order to get angle A, so because we're looking for an angle, let's go back here. Because our unknown is an angle, let's use this format. So sine is on the top, okay? So then that'll look like sine of A over side length A, which is 8.3 centimeters, is equal to, and let's use what we're given. So we're given that sine of B is 75 over 10.4. And these two should be equivalent. So in order to get angle A, let's multiply both sides by 8.3. Okay, and then that means that this is gone. So you're left with sine of A is equal to sine 75 over 10.4 times 8.3. And then we're trying to find A, right? We're not trying to find sine of A. And recall, in order to get rid of this, we need to take the inverse of sine, and that will cancel these out. So that means we're going to have to take the inverse of sine of all of that. Try putting that in your calculator, and you should get 50.4 degrees. So that means that angle A is 50.4 degrees. Okay. And once we have two angles in a triangle, it's really easy to find the third, right? So again, angle C. We know that all the angles in a triangle add up to 180, so 180 minus 75 minus 50.4 will get you 54.6 degrees for angle C. So this is 54.6 degrees. Okay, and then last thing we're missing is side length C. So let's set it up like we did in the previous example. So if we're trying to find a side length, let's use the form of sine law where the side lengths are on the top. So little c divided by sine of big C, which is 54.6 degrees, will be equal to, and let's just use what we already set up before. So let's use B. So recall, so make sure that your side lengths, all of them are at the top. So it's going to be 10.4 over sine of 75 degrees. Okay. And then you know to multiply it by sine 54.6, multiply sine of 54.6. And you will get that little c, and make sure you check too, using your calculator, you should get that little c is equal to 8.78 centimeters. So in this last example, we took a look at using sine law in the two different forms, and I hope that's been helpful. You're going to be doing all of the questions here for homework, and this will help you get more practice and get more comfortable with this. Make sure that once you're done that you continue to check your work on the next page, and if you have any questions, let me know.